I'm going to do a demonstration on how to load an L2 memory substrate with all of the details for TypeScript so that we can have a TypeScript expert out on hand so that the LLM, in this case Claude Code, is able to refer to it and get really expert level information on TypeScript. Now, Claude obviously is a pretty good coder as is, but if you want your code to be meticulous and expert grade, then you actually need some sort of reference that it can use as an L2 cache in between coding sessions. So once your context gets a little bit heavy and starts to rot, you might need to start a new session. In that case, it would then need to reread your code base and learn your conventions. If you're using an L2 cache, it can also basically read the TypeScript guide, and because it's fresh in context, it makes it much better at programming in the TypeScript language. Now, I've just picked TypeScript because it's something that I'm currently using, but it could be any language. And in fact, I also have another one that is an expert on a bunch of research that I'm doing. And what I find is that as I get it to do the web research, I then insert it into the L2 cache, and then I can just ask questions of the L2 cache instead of, going back onto the internet in every session and trying to refresh it that way. So I have just started a new substrate. This is Delta Pulse substrate, brand new. Started today, the 9th. And what I'm going to do is I'm going to grab the URL to the substrate, and I'm going to add it to my MCP file. Now, Claude uses a Claude desktop config.json file, and inside here I'm just adding the URL to the L2 cache, and I'll need to claim the API key from here, and each substrate is locked down to one API key, so we'll just need to add that in there and then save the file. Now, when I start my session with Claude, once this has been set up inside the config file, it should be able to pick up that MCP server and then directly use it. Now, it'll be empty, so I'm just going to start Claude up in a fresh session after I've added that URL and bearer token to the desktop config file. I'm going to start a new session. You have to start a brand new session after saving that file. And what I'm going to do is I'm going to say use this new substrate. Substrate is just a place to put all the data. So an in-memory cache that allows you to very quickly retrieve, insert or retrieve information. So use this new substrate memory. The goal is to read all the latest TypeScript documentation and standards, and create an L2 cache for my subagents to use when coding in TypeScript. And again, this is more of a demo than it is anything else. The idea here is just to have a subject that you can use in your agentic fleet. In this case, the majority of the stack is in TypeScript, so when the agents have questions about what it wants to code, it can actually just ask the L2 cache instead of going on the internet. And again, once you've loaded this up for various use cases, you can update it over time and add to it or blow it away and set it up fresh. So I'm going to say do some web research on TypeScript standards and standards, and then load the cache so we can use it to write better TypeScript. And what it should do now is go onto the web and do a bunch of research from Microsoft. I think Microsoft owns TypeScript, and it would be capable of basically finding the best resource, because it's Claude and I'm using Opus. So now it's coming back. What should it cover? Language and compiler. I think that's probably the most important thing. I also like the idea of having a good style and lint standards. Testing and validation is a bit out of scope for this. We're just talking about writing good code, but let's add everything, because why not? Rules as claims and hubbing, so we want that. And how many atoms? I'm just going to say as many as makes logical sense for how we pack the knowledge into atoms. Now, so this is the first time. Atoms are nuggets of knowledge, substrate only. If you consider that a piece of knowledge can have various relations, an atom is an expression of the knowledge, and obviously there are many different types of pieces of knowledge, and there is a way that we structure this knowledge. I've got a skill that I'll make available open source to everybody, and it instructs the AI on how to effectively use the underlying memory to create a structure that allows you to pack this knowledge into an atomic structure that has various relations between all of the the language that you're using. So you can imagine if you've got research and there is different authors, but they have overlapping ideas or overlapping research. The atoms are designed so that they can make it very easy to draw out the underlying theme of the research, and reference the author of that research. These atoms are sort of temporally and semantically designed to encapsulate more information than just raw facts. So they are definitely a useful format for preloading. And you can think about information processing in two different ways. The first one is pre-processing, the second one is post-processing. This is definitely a case of pre-processing the information in a structured way. And obviously with the power of an LLM, you can pre-process this data very, very heavily. And if you have a ontology that you have in mind for a particular subject or domain, you can instruct it to design its atoms for the ontology that you are working with. I'll give you an example. I have one of these as an expert on my entire SaaS business. So it understands what a substrate is, it understands what an atom is, it understands what a customer is, and all of these definitions have been turned into various types of atoms that have, relationships to each other, and ultimately explain back to the LLM at retrieve time how do these atoms relate to each other. Like a process might have many steps in a sequence, or a fact might be a fact forever. There are various interesting discussions we could have about the English language and how it, how it basically has a graphical structure and a chain of speaking for relaying information on various topics, and this simplifies the process of taking the raw information and turning it into a ontological and temporal shape or structure that is readily queried at a human language level. So, if you pack it up front correctly, instead of having to process it after the fact, what you can do is just ask it questions, and it can draw out the relations and the conclusions, similar to overlapping research by the three authors that we were talking about before. So I'll just explain a little bit about what's going on in the background. I've given it the MCP name, which I've spelled incorrectly, and I've given it a goal. And the goal is to read all the TypeScript documentation standards, create an L2 cache for my subagents to use when I'm coding TypeScript. Now, the first question you might have is, why don't I just use a RAG system? RAG has its place, and RAG can be thought of as quite coarse, and whilst in the human English language or whatever language you're dealing with, it isn't necessarily structured up front. It's kind of chunked and chopped up, and some of the context is divorced from the meaning. The LLM can stitch that meaning back together, but that's post-processing, and by that point you've actually lost some of the information that we care about. What we're doing here is pre-processing. So the idea here is that it will generate an entire corpus of knowledge around, in this case, TypeScript. It will find and categorize the ontology, or the way that the knowledge relates to each other and how you would use it if you're a developer or if you're designing a compiler, or depending on the goal that you have, it constructs the atom structure to pre-assemble the knowledge into a crystalline atomic structure that is easily queried at human speed, at human level later, but is also really useful for agents. The agent itself might not be an expert at TypeScript, and in this case, because it has access to an L2 cache that has been packed with the knowledge of what would make an expert TypeScript developer, when it asks questions about what's the best way to do something, it's basically a fast lookup to that user guide, and we're talking milliseconds. So the response time, because it's an in-memory cache, is very, very fast. So you're not sitting around waiting for a traditional RAG pipeline to, semantically find similar or commonly represented semantic clues that match the overall goal. In this case, you've kind of shortcutted that whole thing and gone, well, we just want to pack it in a way that makes ontological sense. So, turns the language into a graph, and then turns that graph into a series of atoms with relations, and then installs it into the memory substrate so that you can retrieve it later. So, in a way, you're doing all the work up front once, and then any session, in this case, we'll be using Claude Code. Any session in the future, those agents get the benefit of, the answers coming back to you as if it was coming back from a TypeScript expert. Now, this can take a little bit of time. So as you see, I'm sort of part way through, and what is it doing? It's multitasking. It's reading the web fetch stuff. At some point, it should then look at how it's going to insert the data in a way that makes sense for somebody who's actively typing and coding in TypeScript. And if you can imagine that, obviously researching memory and AI memory means that you're dealing with a lot of really complicated subjects. And what I find is that if I ingest all the latest science from the various domains that lead themselves to the creation or design of an effective L1 cache based on the principles of the English language, it stores that information and makes it readily available. It doesn't forget it. So, in the next session, when I say, hey, you remember that piece of research, what did it mean? Or what are the overlapping themes between these two different knowledge domains? It can literally go to the L1, find out what we're talking about, and in a matter of seconds, fill the context with the relevant information from those researchers. Now, I don't claim to understand half of the mathematical complexity that that some of these research papers talk about, but I do know the underlying technologies, theories, and the coefficients that you find, using a biological model. So in the case of an L2 cache, you are kind of looking at that very short, sharp, repetitive response to very, very tricky and technical questions, which, if structured correctly going in, come back really fast in a very useful manner. So even a lower tier model would be able to ask a question, get an answer, and then potentially just jump straight in and start coding with the answer, or from the answer that it got, potentially drill down and do some more searching for related subjects. And this is where the study of relations between various types of information becomes very, very useful. If you know that you're working on a compiler and that there is certain processes that need to happen, if you just ask about a compiler, but you're working on solving a particular problem inside a compilation that you're doing, quite possibly feeding it the error message would help you then debug the problem. And interestingly, I've got one that I use as a coding buddy. It records how I code and what I do, and I had some cryptographic issues 3 or 4 months ago, and we decided that the best way to deal with problems when you're dealing with very complex systems is to come up with one or two very simple ways to disprove that it's actually the complex thing that's the problem, and instead spend a small amount of time on negative testing, or proving that it's not the thing that could be the worst thing that it could be. Sorry about the language, it's kind of how it came out. And what we found was that when we were in a different system and we were working in cryptography, it sort of recommended to me that we try a very simple test to see if it was a complex problem or a simplistic problem. And lo and behold, it was a very simple problem, and it was a mistake made by the LLM. So something to realize here is that upfront work is a lot less painful and a lot easier because you have the time to structure it in a way that makes sense for the way that you're using it than it does post-processing, so after the fact. What you'll find with these L2 caches is that they're designed to be short-lived. So quite often I will come across a subject that I don't know a lot about. I will ask it to research that subject and store all the information into one of these. I will then get the LLM to query, I will raise the research that I want to do and say, hey, how about we try this thing and do some scientific measurements to understand the ins and outs of how this thing works, and reference the research that's in the substrate. And because it can cross-correlate the information very, very quickly, it's giving me much, much better results on how to actually use the science, rather than me trying to read it and understand it and then synthesize from the multiple authors a coding structure that would work across those boundaries. So this is definitely one of those ones where imagine if you're a university student and you're working on something really, really complex, say set theory. You could create an L2 cache that was an expert on set theory, and then you could ask it questions about set that was in your homework. Or if you're working on a project that needed to understand set theory in the relation to database, database science, potentially you could ask it the questions and get the answers really, really quickly, and ask it to simplify it for you so that you can understand the information handed back by the LLM. Because a lot of the quality of the code that you'll get out of these agents when they're in a fleet and they're creating code bases for you, is that the quality of information that it retrieves at start time is as important as the quality of the information that it's currently using in the window. So, the whole concept of what's at the beginning in the window is super important. What's in the middle is super important. What's at the end is super important. And everything else tends to get lost. And the longer the context window gets, the more it forgets the beginning information and relies on the later information. Having a steady state or a steady store of information simply allows you to refresh the context at the point where it's important, which is usually in the current moment, right? And if you're not having to grep the entire project to understand how something works, you can save a lot of tokens, because the tool call and then the response is going to be a lot shorter and a lot sharper and a lot less tokens than grepping large parts of a project. It's not a problem if you're on a tiny little project of a few thousand lines or whatever. But when you start getting up there, 10, 20,000 lines, maybe 50,000 lines, in my case, hundreds of thousands of lines, it's a lot cheaper on your token budget to spend the time up front, store all of the information about the thing that you're coding, and then ask it, what's the blast radius of making this change? What should I be careful of? And in this demo that we're doing right now, please use this TypeScript reference to write the most efficient, efficient code possible, and conform to the TypeScript standard as much as possible. And what this does is obviously higher quality code at the generation point is easier to rationalize about, and in general, if you needed to have some TypeScript explained to you, or your code that's written in TypeScript, you can ask the memory to solve the problem and understand it for you. Now, just wanted to pause here and go over what we're doing here. Is we're packing atoms, so it's taking information out of the research that it's done, and it's generating series and chains of thoughts about the TypeScript standard and how all of the various pieces relate to each other. Arrays and enums and all of the various data science that goes into a language is very, very difficult for a human to hold in his head, right? And as an LLM, Claude itself has been trained on a lot of code, but some of it's good and some of it's really terrible. And in general, its coding abilities are, well above average, but from time to time, really poor practices seep in. So what this is going to allow us to do is to set a standard in L2 cache, teach the agents that they're to check the standard and just use it as a reference. And what this will do is, before it writes code, it's already thinking like an expert, because where it goes to get its understanding is pre-processed into a form of an expert. This definitely means that the code quality you get out of your coding agents is going to be much, much higher. And again, this will work for C, C#, TypeScript, Java, Ruby, whatever domain of knowledge that you want to create an expert in, you can with this process. The reason why I find this so useful is that the average developer or coder can only really keep maybe 2,000 or 3,000 distinct lines of code or processes or modules or whatever in their mind at any given time. And this takes some of that mental load away from you and puts it into a semi-durable store that can be queried in human sort of level questions. And I'll show you once this is all loaded up. You can ask it questions about TypeScript and it'll give you expert level advice, not just the text of the standard that you have ingested, but if you're asking a complex question about how to do something, it will be able to link various different aspects of the language design to give you a much more cohesive answer. So instead of just reaching for that one tool and going everything's an enum, you might set it up, you might ask it a question and it comes back and it tells you that no, actually this other structure's may be better or is better, to do the thing that you want it to do. Maybe the enum is too rigid, or is not the right tool. And in this case, it should actually be able to tell you why, because it understands the context of the language, but also the semantics of the language, and the internal relationships between the different types of data structures and different types of coding practices. So hopefully this is getting close now. There is quite a bit of information on TypeScript. TypeScript 7 is in a Go compiler and is GA, and TypeScript 6 flipped 6 defaults. So most subagents will be working from pre 6.0 for this project, and now it's building the scaffold. So it's figured out the type idioms, and this is an interesting thing here, right? So when we are working in code on projects, the language that you would be using is, SAS and front end and API, or compute layer, or database, and these become the types, and the things that you do to them become the idioms, and we have predicates that allow you to very quickly search for the right type and piece of information that you're looking for. But in this case, what it's doing is it's creating a new discipline for creating atoms for the domain that is TypeScript. And it's doing it for you, right? So this is all designed into the the skill for memory substrates. And it's been taught to assemble the information, understand the information, work out what all of the relations are, and then do an ontological study, which basically just means find the verbs from the domain that matter to the thing that you're feeding it, and create atoms from those domain verbs, and then join them with the relations. So is a member of, can use, is sequential, all of these various different layers can then point back to the original verb and join up in a multi-step process that at the end of the day ends up being more than the sum of its parts. So here we go. So it's saying it's created most of the atoms now, and it's looks to be doing some queries. It's probably testing it out to make sure that if it asks it a bunch of questions, then the correct answers come back. So what's it doing now? It's going to checkpoint. So what it's basically doing now is it's writing a little entry into the the substrate itself, doing a search, doing a bootstrap. So a bootstrap is basically, I'm going to ask you about a subject, and I want you to give me the most relevant information atoms back with whatever related information is useful to build out the context for my next project. So give me an overview of how we can use this TypeScript L2. And this is just for the benefit of everybody watching. It's smart enough to understand why this is powerful, right? So we're using the power of the LLM to look at what we've created, and then to give us back an idea of how to use it. So already know how to use it myself, but this is more for demonstration purposes. If you are running a fleet of agents writing code in parallel, I would have 3 or 4 L2 caches, one that's setting the coding standard, one that's setting the security standards, one that is versed on the existing code bases, and that would really improve the quality of the code that's being generated, but also speed it up and lower the total number of tokens. So we come to the conclusion of this video, and I'll just go over some of the important things that it's done for us, right? So the operating model. If a subagent starts with none of these sessions in context, so the substrate is a transfer mechanism, right? It's an L2 cache. It's how the 700k of tokens of research has just burned to become 1k token read for every future agent. So you can see the compression that's going on here, but interestingly, we're not losing a lot of the semantic, temporal, and relationship data from the original corpus of information that was the TypeScript standard. So Bootstrap is basically get me information plus context. And when the agent doesn't yet know what it doesn't know, it returns ranked atoms plus conflicting facts. So this will clue the AI or the agent in to say, hey, here are two pieces of information, but they are both disagreeing with each other, which is better than having it fail by hallucinating two facts as being true at the same time. So we get a sharper and cleaner Bootstrap. And this one's quite a small one at this point right now, so there's not enough arcs to really do much predicting. So it's designed to get you the information you want plus extra context. So we have an ontology that basically talks about releases, configs, idioms, the lint, the style, the modules, no time, testing, validation, and traps. And then the thing that actually makes it fire. So nothing is actually designed, nothing's been set up to use it at the moment, but when I run some agents that are going to build some TypeScript code later on tonight, I'm going to point this to them and give them the skill that tells them how to use it. It's got some honest limitations. So raw semantic search is noisy on a fresh substrate. So because it's brand new, it's a little bit rough and ready. Once you start using it and reinforcing it, it will actually get a lot easier to use. So for the first few questions, it's a bit slow and it just literally gives you a semantic match. But over time, as it figures out how you're using it, it's reinforcing the relations between the different subjects that you're using. And sorry, that's the doorbell. And I will finish the video there.